This is a question about a line meeting a curve. So there's a tangent. If a line just meets a curve, it's called a tangent. Now, it says in this question, prove that y is equal to x minus 3 is a tangent to the curve, y is equal to x squared minus 5x plus 6, and find the points of contact. So quite often the question would just have the first bit. So prove that y equals x minus 3 is a tangent to the curve. So this is how we have to go about this first of all, and then we have a wee bit extra to do in this question. So the first thing you do is you put your two things equal to each other. So you put your line, which is x minus 3, equal to x squared minus 5x plus 6. Bring everything to one side to put it equal to 0. You'll then have x squared minus 5x minus another x, so minus 6x, and then plus 6, and then plus 3, so that's going to be plus 9. And then really what we need to do here, the way this question is worded, it is a discriminant question. So you've got three situations here. If you imagine you've got a curve, the first situation is, and this is the most likely one really, I'd imagine, is this, that a curve and your line meet at two distinct points. And that means, if you look at your quadratic curve that you've got, if you imagine it is ax squared plus bx plus c equals 0, then that means the discriminant, which is b squared minus 4ac, so in this situation, b squared minus 4ac will be greater than 0. It will be greater than 0. The second situation, which is this one here, that means the discriminant will be b squared minus 4ac will be less than 0. That means there's no real solutions. And the last situation, which we are going to be in here, now it might not be like this, might not be this shape, but you've got your curve, and here, if it's a tangent, then b squared minus 4ac is going to be equal to 0. And that gives you one repeated root, or one distinct root, distinct root you could say. Whereas this one gives this one here, middle one here, sorry, this one gives you no roots because they don't meet. And this one here gives you two distinct roots because it meets in two places. So you're investigating b squared minus 4ac, and you're saying, is it positive? So is it greater than 0, which means there will be two distinct roots? Is it negative, so is it less than 0, which means there will be no roots? Or is it equal to 0, which would mean then there is one distinct root, or one repeated root, i.e. it is a tangent. So we're going to have to investigate b squared minus 4ac and see what it is. So you don't just put that it is equal to 0 or anything like that. You look at b squared minus 4ac. So b squared minus 4ac in this question. Let's get rid of all of that. So here, b squared, first of all we'll just say a is equal to 1. Your b is equal to minus 6, and your c is equal to 9. So we're going to investigate b squared minus 4ac. So b squared minus 4ac, that's going to be equal to minus 6 squared minus 4 times 1 times 9. And if you do minus 6 squared, minus 6 times minus 6 will be 36. Minus 4 times 1 times 9 will be minus 36, and it is equal to 0. Just say, therefore, one repeated root, i.e. the line is a tangent to the curve. Now, what we've got to do next is we've got to find, in this one, quite often that's all you would have to do, but in this question it says, and find the points, the coordinates of the points of contact. So we're going back to our equation that we have up here. So now what we have to do is actually solve that. But if it didn't say find the points, you're done. That's all you would have to do. So what was our equation? Let's just write that down again. 0 is equal to x squared minus 6x plus 9. Then we'll zoom in on this thing again, and we will factorize that. Now, you should be able to see that factorizes to be x minus 3 all squared. But if you don't see that, just do your sum and product. Sum is equal to minus 6. Product is equal to 9. Go through 9. 9 could be 1 times 9. It could be 3 times 3. But neither of those are going to add to give minus 6. We'll change them both to be minus. And then minus 3 and minus 3 work. And then you can, because the coefficient of this here is just 1, you can just jump to your factorizing. Factorized version, it's x minus 3, which is just the same as x minus 3 squared. So put that equal to 0, put that equal to 0 and see what you get. So that means we're going to say put x minus 3 equal to 0, which means x is just equal to 3. And remember, it's a coordinate, so you've got to find the corresponding y value. So to find the corresponding y value, I'm going to put it back into this thing here, the equation of my line. Y is equal to, very blocky there, y is equal to x minus 3. So I would just say sub into y is equal to x minus 3. So just say when x equals 3, y is equal to 3 minus 3, so y is equal to 0. So your point, or your coordinate, you could have said, point is 3, 0, and that is you done.